Hi, everybody. Sorry for the small inconsistency. I'm Steven. I'm the Axon Framework Lead Developer at Axonic. I hope you've seen Allard's talk just now about what we do in this entire scope, because I want to jump over very quickly to actually live coding. This also means that if you have any questions, please leave them till the end. I honestly wrongfully assumed I had an hour. I only have 40 minutes, so I need to jump a couple of hoops, which I'll do my best for, because obviously I want to help everybody. I'm going to do an hands-on intro into CQRS and Event Sourcing with Axon, mainly live coding. As pointed out, I'm making a couple of assumptions, so known concepts for the audience. If not, there's a likely time for questions at the end, or maybe at a different stage. First one of these is I'm going to use domain-driven design, or DDD for short, in the app I'm going to build. What this roughly means is that I'm using domain models to describe my application. So models consisting out of things like entities, value objects, and aggregates. Especially the aggregate is something we'll see coming back. We'll kind of pair this up with CQRS, obviously, because CQRS is part of the title. So what this means is I'm doing command query responsibility separation. So in essence, separating concerns of doing commands and queries. So commands, the expression of intent to perform an action, and a query, the request for information or state. At the basis, this means two APIs, but I'm going to pair it up with DDD. So I'm going to do two types of models, a command model and a query model, which we'll see in a couple as well. Thirdly, event sourcing is always going to introduce here as well, meaning I'm going to source every model through the events. So not just the query models, which typically stream all the events flowing through your system and update themselves, but also the command models, which make the decisions and publish those events to recreate themselves time and time again. That's what event sourcing would be. And lastly, well, I assume this is a fair assumption to make, that microservices is a known concept, but I want to focus on it regardlessly because of the talking aspect. For those who've seen Allard's chat right now, he also points this out, because when it comes to microservices communication, a lot of people just think about doing these events, but we're not just going to do events. We're going to use commands and queries as well. We don't only have notifications of past tense things that have happened, because that would mean we are always communicating in the past tense. It's not going to be very helpful. We want to be able to express the changes we want to do to specific model instances, route those consistently. We want to be able to request information, maybe from one source, from several sources, or subscribe to those sources. We need to have these three messages to have a clearer and cleaner separation. This also signals that we don't use a single message bus. We use an event bus, a command bus, and a query bus, all with their own routing needs. So with that in place, this is going to be the basis of the API we're going to construct. Let's have a look at what the application will look like I'm going to build. So I have a very basic diagram here. I've got a controller on top to enter the application. This controller will dispatch the commands and queries, for example, which will go to command and query handling components respectively. The command handling component would make a decision by consolidating the domain model, the command model in this case, and publishing an event if it's happy with it. That event is going to be handled by an event handling component, updating other types of domain models, the query models down below, which are going to be returned by our query handling components whenever somebody is querying it. You can directly see our messages being placed on here. We can already assume as well that this is going to be a microservices architecture. I'm, however, not going to make it into microservices right away. I'm just going to make a single monolith because, well, we can. If we just separate our concerns clearly enough within that one application and make it modular, we can make that journey as the need arises. Time to introduce the demo. I'm going to use a rental application, game rental application is going to be the domain. And I've already decided what the API is going to be. We have a command, an event, and a query API, and that's what we share with everybody who wants to connect with our app. So that's what we do with the outside world. We can register a game, rent a game, return a game. Sounds feasible. Those commands will be handled by our command model, which will consolidate it, validate it when it can happen. And if so, it will publish a registered game event, rented or returned event. On the other side, we have the queries, and we are able to find a specific game. So we can do a find query, returning a game as a response. And we are able to watch the catalog of games. So whenever a new game is registered or released, the titles are updated and pushed. Okay, again, in favor of time, I've got a couple of dependencies prepped. So I'm going to use framework. Obviously, I'm going to do Spring Boot to quicken it up. Our controller is going to be through RSocket, because I think the idea of RSocket combines very well with that idea of messaging and asynchronousy. Reactor extension in there from Axon to use Mono and Flux, and a basic database and web dependency. This, however, doesn't give me a start point. I don't have anything ready yet. I don't have any code. I don't even have an event store to store our events in, or a messaging paradigm. Luckily, we got Exonic Initializer and Exonic Cloud. So Exonic Cloud is a pretty recent release, this week actually, where you can use a dedicated message bus in the cloud and a dedicated event store by connecting your application to it. And I'll show you how. I also got the Exonic Initializer, which I'm going to jump over to right away. So what I have here is start.exonic.io. For those who've done start.spring.io, this is obviously the same thing, but now with our flavor on top of it. So I'm going to set all the defaults. Right now, it's really just a flavor thing. And we are going to introduce more biased concepts, like how you want to package your structure your packages and where you want to place things in, how you're going to connect to services. Right now, this is what it is. We will expand this eventually. Maven project, Java. I'm going to use Java 11 for the time being, because we still need to do a little bit of work to make it Java 17 compliant. Will come soon though. Let's go to the dependencies. As pointed out, we're going to do reactor, not the rest. I want to have web in here. Let's do reactive web. I think it's there. Our socket, no security needed. Yeah, and data JPA and H2 as a database. And yeah, that's it. Let's download this and store it down there. Now I can go to terminal, unzip this package here, and here we have it. So I'm going to start literally from scratch, and well, it apparently always does that. I'm not sure why. If somebody does, contact me. Maybe you can help me. Well, let's start up the project. So this is presentation mode. I do hope this is visible. If not, drop me a message in the chat. I can help you out. So we got our basic app. It's really nothing different than what you'd have from a regular Spring Boot application. The main specific is that we have an Axon version and the Axon BOM attached to it. This Axon BOM, the bill of materials, ensures that you all have working components or release versions together with one another. A definite recommendation. Now, I'm going to quickly introduce an application config because I need this. And now this is how I'm going to make it quick and doable. I've got a live templates up my sleeve. So I have prepped IntelliJ. I haven't prepped my project, but I have done this the other way. So I've seen this before. Sometimes it does this. Now it should work again. All right, there it goes. So see, just another configuration, add configuration annotated because I'm in Spring Boot. And there are two things I really want to focus on. Firstly, I'm specifying Axon serializer. By default, it would do extreme. Not very nice to do it in XML anymore. I want to use JSON. So I want all my messages, commands, events, queries, and their responses to be Jackson serialized. And I do that by defining this bean with this qualifier. Also, as this is a demo, I want to show the messages flowing through my application. And sure, I can eventually go to Exonic Cloud to show all this, but I also want to see it in my app. So I have registered a logging interceptor. For the more intricate knowledge in here, this is a type of handler and dispatch interceptor. So whenever you're sending a message and handling it, this thing will be invoked if you have registered it. So that's what I'm doing. I'm providing the bean and registering it on the command bus, on our event bus, on the event processing configurer to be used by all the event processors. In essence, these are the event consumers. So you'd say, so whenever we're handling an event, we'd also log, and we do it on the query bus. There's one sneaky thing in here I sadly need to do it to our socket. I'm not going to focus on this because it's not important for the demo. Now, let's start by adding another package. I'm going to call this the core API. I'm going to introduce a dedicated package where we're going to contain all our messages in, because I already want to do a clean separation within my one application. For those who've seen the previous slides, you know what type of messages I'm going to introduce. a register, rent, and return as a command, as an event, and a find game, game as a response, and a full game catalog query. So let me first introduce all those empty classes. So let's not make any typos because then it's not going to work. Here we have the first one, then we do the rent one, then we do the turn one, then we go back here and we do another for game registered events. My hands are terribly cold, sadly, because the weather is terrible up here. So I tend to be a bit more fluid, but this is what it is, right? Oh, this is the wrong button. Come on, give me back my IntelliJ. Definitely what I said. The coldness of my hands not working with me. Okay, so game returns. We also go for the find game query without a typo, the game response, and the full game catalog query. So a bunch of stuff in there, pretty basic. These are just POJOs. I want them to be immutable objects. I want them to be a type of data carrier, really. They're going to carry the registration of a game in this case. Again, pretty boring to see. I got this prepped up. So I got my annotation in here to make it work with Jackson. I got all the fields are required to register a game. And we can see we only have getters and equals and hash code and a toString. Now, just make it final. Do make them immutable. We always recommend this because this is just the better way to go about it. There's one additional thing we require on our commands, and that is to identify what the field is to route the command consistently with, because we want to consistently route the command to whomever is in charge of making that decision. So in our case, that's the command model, or more specifically, the aggregate we're going to construct in a couple. So we need to identify what the aggregate identifier in this command is, the target aggregate identifier. For that, we have an annotation. So always add the target aggregate identifier if you have commands which are going to be routed directly to an aggregate. This is essentially it for the register game command. We can do a similar thing for the rent command. Just got it crapped up here. You see, you got a different set of fields. Again, our target aggregate identifier targeted towards the game we're going to rent, and whoever is going to rent it. We're going to do a similar thing for return. Okay, got it. Pretty basic. Let's go to our events. Again, I've got these up my sleeve, and they're pretty straightforward. This is really a flip side of things. You see, I'm having a command in the current tense because it's an expression of intent to do something, and an event in the past tense because it has happened. Now, right now, it's really registered game, game registered, rent game, game rented. This doesn't mean this is always the flow. You don't necessarily need to publish a single event or any event at all when you're handling a command, or a one flip side of it at all. You can do any type of format. Right now, though, for this demo, it was most reasonable to do this flip side solution. You will see when you're actually building such an application that you'd have different events. Let's move on and fill in the rest, because as we see, they're flip sides, as I pointed out. Really just stating the fact that a game has been returned in this case. And now you might think, why am I watching all these messages being constructed? Well, normally this would be prepped up front. This is something you would decide on in an event modeling session, for example, or an event storming session, like Alec pointed out. Also, two of my colleagues, Sarah and Ivan, will do a workshop where they're going to show an event modeling session, just deriving this API. So we should just assume that right now, I, with my team, have already done this design, and I've known what these messages should be. So I'm just punching them in the boring bits of the code, really. So find game query based on a game identifier, straightforward. We got a game response as well. This is a bit more fleshed out because it returns the title, release date, description, whether the game is single player or multiplayer. The full game catalog query is kind of boring. I'm just going to introduce a toString method. And the reason for that is this is essentially a type of find all. I wouldn't necessarily even need to use a class for this. I just want to make it very apparent from our core API package that we have this full game catalog query. So I'm making one so that I can use it in a query handler later too. Okay, we got our core API. We can start actually thinking about these distinct packages, the command package, the query package, and the controller side of things. So to introduce our command handling components, event handling components, and query handling components. First of these is going to be the command package, because I want to have a clean separation already in my single app. And we need to introduce a class which is going to handle the registration of a game, the renting, and the returning of a game. So if you think about this, we're registering a game, a single one. So it sounds reasonable that our command model, our aggregate, is going to be the game. So let's just call it that, right? And this might feel a little bit off because I also have a game in my core API, but those are distinct things. For the fact of this demo, I'm not doing them in separate repositories or separate modules. I'm just doing it in a single thing. But I can do this as well on this level, just by making this package private, just by being certain that nothing else can access this game, only if I'm on the command side of my app. So let's do that. And you'll see me doing that more often. I'm going to introduce a profile as well, because I am going to try to distribute our application as well. We're going to introduce our first Axon annotation in here. I'm adding the add aggregate annotation so that the Axon context, together with the fact that we're running in Spring, knows that, okay, this class has command handlers, might need to be event sourced, needs to be stored somewhere, have those command handlers registered to command bus. Just using this annotation simplifies our configuration greatly and does that for us. So just use that. Now we can move on to one hard requirement. Axon requires a no-op constructor, and I'm introducing another one for the register game command. I think that's fair, because the register game command is the place where we actually start the game. So why not do this on a constructor? At this moment, though, Axon doesn't know that this constructor is intended to handle the register game command. It's not able to automatically register this operation to the command bus. For that, we're going to use the add command handler annotation. And we'll see more of these types of annotations, mind you, to register all the type of message handlers we have. In this case, we're doing an add command handler so that we know this is a command, a method able to handle the register game command, which will be registered to the command bus. So whomever is dispatching this command will make it route to this constructor. This would be the place we're going to start doing decision-making logic. Now, when it comes to registration, I have decided, let's assume I'm also part of a business and some other people in there, we have decided that registration is just fine. Somebody scanned a new game for the store, and we're just going to introduce it. This means that whenever we're handling this command, we can simply publish the fact that it has happened. So we can start publishing an event. We need to do this within the lifecycle of a specific aggregate instance we're creating. So for that, we use the aggregate lifecycle.apply method from Axon. And mostly I've got some live statements more. With this method, the apply method, we are certain we are introducing this event, the game register event, within the scope of this specific game. So this, by the way, this apply can also apply several events if you want, as I pointed out. Now, I pointed out it will apply an event for a specific game. However, this aggregate is not identifiable at this moment. We know that the game identifier, which I've set up here, this field, that this is the target aggregate identifier. However, we haven't coded our aggregate such that it knows what the aggregate identifier is. So we need to do this. This is the sole hard requirement every aggregate would need, an external reference so that it can be accessed. This also is our entry point into doing event sourcing, because we need to handle the game registered event to set that state. So by doing this approach, we're doing a very rough separation of decision-making logic in our command handlers and state changes in our event sourcing handlers. This is what you would be doing if you're doing event sourcing with Axon. I'm going to grab the game identifier, I'm going to retrieve it. I'm kind of lost on what that annotation was. So I'm going to do it like this. I've got this field and I need to make this an aggregate identifier. drop this like so. So by annotating this field with the aggregate identifier annotation, I tell the framework this field or this getter is the identifiable unit into this aggregate. This doesn't necessarily have to be a string. This can be a UUID. This can be a typed identifier, as long as the object you use has a dedicated workable toString operation sharing something nice. So this is why I'm doing string for now. And also, I don't have time to do typed identifiers, even though I would recommend that. Okay, we got our first couple of steps. We can start introducing our rent game command handler and our return command handler. For this, I have specific Axon live templates up my sleeve. So I've got a rent game command handler, and well, we're just going to apply right now, right? We're going to do a game rented event. We need to provide the game identifier, which we have as state, and we need to retrieve the renter from here. All right. Okay. So we can do a similar thing for the return. So let's do just that. And this is not going to work, of course. Need to fix those import statements and make this a returner. Nice. This is pretty boring. It's not making any decisions. It's just ingesting a command and publishing it as a fact. I don't think that justifies a demo where we show this stuff. So we're going to introduce some business validation. Business validation would reside inside your aggregate. That's the ideal place to do this at. So what I've come up with, and I think that's fair, honestly, if you're a game rental shop, you have a set amount of games you can rent out, several instances. So there's a notion of stock in place. So before we actually apply the game rented event, we need to validate whether there is sufficient stock. So for this, I actually prepared another live template. We see that I'm going to validate whether the stock is smaller to 0. And if not, I'm going to throw an illegal state exception. Note that you don't necessarily have to throw an exception if you're not happy. You can also simply do a return so that it's a silent failure. Not always ideal, because this is when the command dispatching end sees, okay, I've just ingested the command, everything was okay. If I throw an exception, the command dispatching end also knows that it's failed. So that's a bit nicer to work with. Now, we got a notion of stock. We need to set it up somewhere. So let's introduce it here. I think that the game registered event is the fair place to do this at, because, well, this is essentially the event sourcing handler constructor. This is the first event of our aggregate, constructing the basis. This is my personal flavor. You don't have to do this. We also need to change the stock. So this signals we need to have additional event sourcing handlers. And this is the first moment we really needed them. We didn't need to handle the game rented event just now for event sourcing because we didn't require any state from it. But now we do. We need to adjust the amount of stock we have. So let's do that like so. All right. Okay, let's do a bit more validation. I've got another one up my sleeve, which I've called unreleased. I think that's fair. We check whether the release date is met before somebody can rent it. And otherwise we don't. We again throw a legal state exception. Well, for those with the keen eye, we saw that the game registered event had the release date. So we're going to grab it from this event sourcing handler. Like so. I'm going to make this into a field again, and we got the release date. And I got the last one up my sleeve because I want to show this. This shop has decided that whoever rented the game should also return the game. Pretty strict. Well, it's just for the fact of the demo. I think this is fair. So I got a renter in place, and we'll validate whether the returner actually consists in the renter. This is obviously going to be a set. Again, I'm going to construct it right here. As set. I think that's fair. Make this a field like so. This is a regular set of type string because we're going to contain those guys in. Also, we need to adjust this. We're going to add event.getRenter. Remove and get returner. All right, we got our basic aggregate. We've defined all our command handlers and the publishing point for our events. In favor of time, we're going to immediately jump over to introduce the query side of our application. As you might have assumed, I'm going to introduce another package because I want to have clean separation again. and I'm going to introduce another class. I'm essentially going to introduce our query model. You've seen I've introduced H2 with Spring Data JPA. So you might have guessed I've taken the assumption I'm going to store it as a regular entity. That's what I'm going to do. Honestly, I could call this the game as well. I've already decided to call it the game view just because I felt this was a bit more reasonable. But yeah, well, it is again package private because it doesn't need to access or exit the query package at all. So just make it package private that whomever is in there can access it and nobody else. Well, we see the basics of the state and such, just some getters. I got an additional increment and decrement for the rented and returned operations. Okay, for this, we also need to have a repository in place, like so. I'm going to extend this with JPA repository. I'm going to add the type in this and the profile annotation, because I do hope to be able to show all this goodness. Okay, we got the model, we got the repo. We don't have a place to project the events yet. We don't have our event handling component. For this, I have the game catalog projector. I've called it the game catalog projector because it's in essence going to return us the game and the catalog. So I figured that was fair. I'm also going to make this a Spring component. The fact I'm doing this is because I'm in a Spring environment, and that combined with Axon will tell the framework, okay, I need to scan all your beans if it contains message handling functions so that I can register them to your right buses. So it simplifies our configuration even further. I also have the profile in here because this belongs to the query package. I'm introducing another specific from Axon. I'm going to make it a processing group called catalog. The fact I'm doing this is because that allows me to group several of these into one process in one transaction as well, but also because that gives me a simple means to fill the properties I forgot to add. So here are my base properties. I should have added that before. However, well, quick demo time, right? So I'm going to do Axon event handling processor catalog. I'm going to change the mode to pooled because this is a more efficient mode. I'm going to do another one for thread count, which I'm going to change to 4. And I need to do an additional thing. I need to copy this and add another package. And we'll see in a couple why we need this. And this is where I'll add my RSocket properties to. Okay, the basics. We can go back to our game catalog projector and actually start using our repository and adding some handlers for this. So I'm going to do a private final game view repository. Wait, that's not what I wanted. Repository. Okay, add constructor. And I'm going to do more live templates. You see I'm doing an event handler. This is not an event sourcing handler. The fact this isn't an event sourcing handler, but a regular event handler is because this game catalog projector can handle all the events from every aggregate. So it is streaming events. It's getting the entire stream. Whereas when it comes to an aggregate being loaded based on its own events, you're just reading its own events. You're sourcing a specific aggregate stream. So Axon framework makes a deviation here between event handler annotations and event sourcing handler annotations. Your aggregate would contain event sourcing handler annotations, and regular event handlers, like this one, for example, that update a query model, which use the add event handler annotation. We need to save our game view. Luckily, I've got this live templated as well. Straightforward, just editing all the fields from the event and setting them in the game view. We can do a couple more of these. I'm going to do the game rented event right now. I'm going to do repository.find by ID, event.get game identifier. I'm going to return the result. If the result is present, I'm going to do result.get.decrement stock. Now, in fact, I'm doing it like so because I want to be protective and throw an exception if the event isn't present or if the field isn't present. Sure, you would anticipate it is, but if it isn't, we know there's something wrong with the database. Definitely something we'd want to signal in our system. So I'm doing that deliberately. I'm also going to do this with game returned. Looking the same, right? Just a different method. Okay. We have got our event handling component done. we can start looking at our query handling component. Now, we could introduce a different class, but this game catalog projector is in charge of the game view, the component which we also want to use as our response unit, as our game response, and the means to send back our titles. So we're going to add the query handlers in here, because that's just, well, this is where it resides. This is the unit that is in charge of all of this. I'm going to use the game as the response. I'm going to find game query as what I'm getting as a query. I'm going to do repository find.id, game identifier, and then I'm going to map it. And I'm mapping it because I don't want to return the game view. I don't want to tell the world I'm using an entity. They don't care about that, nor should they. I want to separate those concerns. So I'm mapping it to something else. And you can see that I am using this beauty again, because I feel it is only reasonable to throw an exception if it's not found. Okay, the last one. I'm going to do the full list query. I'm going to return a list of strings because those are the titles. The titles of our game catalog are just going to be, well, those strings. So this is going to be easy. It's going to be a repository find all, and now we need to map them to game view get title, then collect them to a list. All right, there's one misser. We don't have a means to update automatically. Right now, somebody would need to query every time and time again if it wants to be kept up to date, if it wants to watch the catalog. However, we can do this in Axon as well. We just need another component, another piece of infrastructure, the query update emitter. So through the update emitter, you can tell Axon, okay, whenever I'm handling this message, I want to emit an update to these queries. So what I want to do is whenever a new title is registered, I want to emit an update to whomever has done a full game catalog query. So that would be the first field, basing the query I want to react on. Secondly, I provide a predicate so that I can, well, check the contents of the query. We know this is a find all, so we just do true. And we want to return the update, which is going to be the title. Okay, so we got this. We need to jump over immediately to our controller. So that's what I'm going to do. I'm going to introduce another package, the controller package, where I'm going to introduce the game rental R socket controller. And again, you might have guessed it, I've got live templates, profile, making it a controller, and I got DTOs to store the data in. I need to have a means to dispatch messages from here. And this would be a place to use the command bus and the command gateway, however, or the query gateway, query bus, my apologies. I'm using, however, gateways because those provide a convenience API. I'm using a specific type of these, which is the reactor one, so that I can use monos and fluxes, because that's nicer to work with. Okay. This means I can start introducing the register, rent, return, find, and watch. So let's do that. Again, some live templates up my sleeve. I need to introduce a message mapping for this. This is how it would work with our socket. And I need to use the command gateway to send the message. Can you do a single send or send all? I'm just going to send a single command, or I'm going to do the build like so. Favor of time, I'm immediately going to introduce the rent and return. You see here, I'm returning a string because I'm creating an instance. This would be the sole moment where I'm actually returning something else than an OK or a not OK from handling a command. Identifiers are fine for the new entities you constructed. You don't share the state directly from a command response though. This is what queries do. This is where you would use a query. This is also why I'm for rent and return, not returning anything. I'm just ingesting the command and giving a mono back to subscribe them. Also want to do this one. Obviously, we're going to use the query gateway. We're going to bunch of operations. We can do a direct query through this. We can subscribe, as we'll see in a couple. We can also do a scatter gather. So we scatter our query out and gather our results. For this case, I'm just going to do query however. So I'm going to do new find game query, add to the game identifier, and do the class like so. And the game catalog, you see I'm returning a flux here, and I need to do a subscription query for this because I want to subscribe to those results and get a stream of things back. Okay, we got everything except the connection with Axonic Cloud. And I got a time point there. So we quickly move back to this guy, go to cloud.exonic.io so that I can actually connect my application. You can see I'm already logged in. I'm on my workspace called this Stevosphere. This is my test workspace. Don't touch it, it's mine. What I need to do here is, well, on the dashboard, you see there's nothing here. We need to start by creating a context. So let's start by creating a context. I can add one. I'm going to call this the game rental context. And I need to decide what region this is going to run in. Right now, we just got Belgium. It's very fresh. We're definitely going to introduce more regions soon. So stay tuned for that. I'm going to the region Belgium. I can select some contexts. I could do for a paid variant or multi-zone variant, being a bit more protective. I'm, however, going for developer because that's fine for me. Context has been created. Right now, I need to make a binding with my application because I want to connect that application I've got prepped up with well, the cloud. So let's do this. I'm going to create an application binding with the same name, call this game rental, and I'm going to save this. This typically takes a little bit because that's well, what it does. And I get a key. I get a basic configuration. Don't close this window unless you have copied this stuff, because you would lose that token. You would lose your connection point with the app. So I'm going to drop it here. And now we have a mean to make some run configs. And let's see, this is the terrible bit I would have wanted to have prepared earlier. But yeah, this is what it is, an empty slate. I'm going to do a command one for the command profile, query one for the query profile, and the controller one for the controller profile. So you're seeing I'm doing very quick means to make this work. I'm going to run this guy. And I got my game rental application, the command side, hopefully doing its thing. Yeah, it started up. So we can close this so we can see the log messages in a couple. I'm also going to do the query side. Let's hope the demo gods are kind to me today. I've already been a little bit of an ass, but yeah, well, that's it, right? Shouldn't be doing live demos otherwise. So, and the controller application, and everything seems to be starting up. So that's good. So what I can show on the dashboard is, well, we still have our application bindings and our contexts. We now actually have our applications up here. We see the specific Spring application names I've been using. So we've got a query side, able to handle queries. We have a pooled streaming processor to handle events. We similarly have a controller, not handling anything because this is just a dispatching unit. It is connected to the buses though. We've got a command side, able to handle these commands. Now, with that said, I think it's time to actually show some stuff. I need to use RSocket in this case. For this, I'm using the RSC, so the RSocket CLI, essentially doing it in debug, so you see a little bit more. I'm doing a request response because I'm requesting something, and I'm routing to register. You see I'm providing the JSON to register the game called Hades. If you haven't played this, definite recommendation. Awesome stuff. All right, so we saw some metadata flowing through the actual payload. We see a response. So I assume the game has been registered. Now, in favor of time, I'm immediately going to do the other operations. So I'm immediately going to rent a game. So in this case, Ben Wilcock is going to rent 8668 as a game. We don't get a response because we made this a fire and forget. Similarly, if somebody else does this operation again, so if I try to rent this game too, we wouldn't see an immediate response here because, well, it doesn't. We don't return anything. Over here, though, we definitely see our exceptions. We can also see that the controller end was only dispatching commands. It didn't handle anything, didn't handle any events. That's not what it's doing. It's just dispatching commands. And we can see that right after the second rent, it failed with an exception. On the query side, we also only see a single game registered and a game rented event, which are executed successfully. On the command side, we see a more expected thing. We see the registration and the publication of events, and similar for rent and the exception that insufficient items are in stock. We can do a similar thing for return. So we do a return. We can see that this is a fire and forget through this. Ben Wilcock returns. I would assume this works as expected. We can also do a faulty return. So we'd see a similar scenario. We don't see insufficient items. We see that a game should be rented by whomever actually, well, rented it out, and the first one did work successfully. All right. I think it's fair to show the queries as well. So we do a find game query, and we find a single game. We got Hades, and we see where we again do a request and response. So a request to find with the data being the identifier, because that's how it was designed. Let's show the watch that this also works as intended. So, okay, we just have a single one. It's trailing. I think it's nice if we introduce another of these guys. So let's introduce another terminal, and I'm going to register a second game. What I'm going to register is Horizon Forbidden West, hoping this is going to be awesome and a bit of Dutch glory there. So registered Horizon Zero Dawn, and we already saw it popping up here. And we can again see that everything works on our query end. You see the queries being handled as well, with the responses going through, and the controller actually, well, sending those queries. Well, I am slightly over my question time limit. I'm going to show a single remaining thing. If you'd ever be interested in what's happening, oh, no data available. Well, luckily I know this is because I'm very likely logged out, and I don't see that is, but let me try that again. Okay, I definitely want to show this, but it's important because your events are stored here, right? I need to select my workspace, go to the event store, go to the event store. Yeah, now I can select it, and I can see all the events that have been stored. I can click them, you can see the stuff, you can see we've been doing it through JSON. Now, without further ado, I'd like to give you some time to actually ask questions, but not before I've thanked everybody for being here. Thank you very much for attending me this session. I hope it was followable because it was extremely quick because I had to. There is a sample application out there, even though I've done this from scratch. I've already prepared this. So definitely go look at my private repo over there to give it a look. If you're interested in framework, go over there. And there's a QR code if you want to have a bit more information about not just my talk, but also Alert's talk and Sarah and Evan's talk. So that's all I had. I think we can jump to questions. We can look at the moderators because I think I need to go to the comments section, but I see the comments section has been pretty busy. I see that I've had some people answer some queries for me. Thanks for that. Yes, thanks, Bill. I'm very happy that this worked out as well. Okay. What would be reasonable? Do people want to raise their voice? I'd be fine to hearing some voices for questions, or raise your hand maybe. If there are any questions, of course. I believe it's going to be recorded, Steve. I believe I've got a notification that's going to be recorded prior to me starting it. And I'm pretty certain they're going to drop it on YouTube. I'd hope so, at least, because I want to be able to share this as well. Okay, you can have a look at the sample code repos. Thanks for sharing that, Lucas. That's a good share as well for distributed exceptions. Yeah. I can actually show that in, okay, it will be available on YouTube. Thanks, moderator. Good to know. That's great. Yes, Clemens, you can watch it with a slower speed. Again, as I said, my apologies. Well, next time around, I'll try a different route. Good question, Bill. Is consistency managed by Axon framework? And thanks, Simon. I've definitely done my best. So consistency-wise, what the framework does is consistently route your commands in a distributed fashion. So it uses consistent hashing under the roots to look at, in this case, the target aggregate identifier, actually, so that annotation doubles as a routing key annotation. I can actually show this. So if I go to the command and if I click the target aggregate identifier, you see it's meta annotated with routing key. And by default, Axon's command bus uses an annotation-based routing key resolver to see what field to base the consistent routing on. This consistent hashing algorithm ensures that every command, or if the routing key is similar, it's always routed to the same instance. This ensures we don't have to do a type of distributed transaction that an aggregate can be loaded on two instances, because that would be a concurrency issue if on two places at the same time a command is being handled and events are being published. If this does happen though, your event store should be your protective measure. So this is also built into Axon. If you are handling an aggregate at two places at the same time and trying to publish an event for both, one of them will be first, always. And there's a uniqueness constraint on a combination of aggregate identifier and sequence number, ensuring that the second one will fail. I hope that answered your question. I also got a notion of retry and back out. Yes, there's a retry approach in the framework to retry operations. Okay, reading the comments here. Is there an issue using gRPC for the controller messages? No, not necessarily, Mark. You could use gRPC directly if you will. I just wanted to show our socket in this case because I like that. But yes. All right. Very good intro into the framework. May I get the chance to give it a private try to get a bit more deeper connection? Maybe in the near future, I can share the example we look for. Sven Eppe, definitely. I'm always willing to communicate about this. You can see in the presentation, at least my Twitter handle, where you can focus on. You can see my repo. You can always contact me over here. You can see my names. You can find me if you will. I've also got my LinkedIn information on the speakers page. So feel free to connect with me. Good question, VJ Sonny. Does Axon work with Micronaut? Yes, it works. I would very much like to see a type of, well, configuration, auto-configuration like we have with Spring Boot. So that's definitely something I have in the back of my mind. As soon as we have time for it and we have built it, we will be, well, sharing that big. Be certain about that. But I'm very certain a colleague of mine has very recently tried it out, worked out. So it is doable. You would, however, be using Axon's configuration API to configure everything by hand. So still, I think the configuration API is very helpful. I have deliberately not done this in favor of time. So just using Spring's annotations is, well, quick in this case, and it's already in place. I hope that answers your question. Okay, got you, Sven. Bill shared the zip file. Thanks. You can indeed also run Axon server locally if you don't want to use cloud. Yeah, there's a zip file in that attached over there. Thank you, Kurt. Indeed, I've got a bunch of, we are trailing Stack Overflow for any Axon tagged question. So not just me, but any developer we have at Axonic is trailing that channel. So we actually got a personal Slack channel which pushes everything. We just, well, we check whenever something new is arising and we try to answer it. And I'm pretty active on there, but also Lucas, we have seen in the chat, is pretty active in there as well. Same for Allard, but also the majority of our developers. Marcel, will it work with storing events in an H2 database? Yes, you can, Marcel. The downside of, well, arguably the downside of using a relational database is that a relational database by design isn't optimized to being an event store. For an event store, you need to be able to read events for a specific aggregate, read all the events from a point in time, only append events, just adding, no updating, no deleting, and validate a sequence. Whereas any relational database is optimized for all the types of queries you can. So there is going to be a certain cutoff point where your H2 installation is not going to cut it as an event store. Sure, Axon Framework provides this. There is a means to use relational databases through JPA or JDBC. However, we have been accustomed to recommend that a dedicated event store, definitely in the long run, is going to save you a lot of infrastructural headache. So it keeps you to focus on your business functionality instead of that you need to jump back to figuring how I'm going to configure my database. So it's a choice, but you can. Yes, indeed, Jan. In the past, this was definitely the only case. So Axon Framework has been around for about, well, 11 years already. Yeah, and just recently, more recently, already 4 years ago, Axonic started as a company, and well, we started constructing Axon Server, because when we asked every user we had of Axon Framework what the major pain points were, that was messaging and that was event storage. So that's why we're here. So that's why we're trying to do this. All right, I see I have got only 10 seconds left. So I'm assuming my time is up. Again, I'd like to thank everybody for sticking around. I hope you enjoy this, and well, watch it back on YouTube in a slowed fashion. Cheers, everybody. Enjoy JCon.